All right, let's moving on to an acid-base titration, which is the measuring technique for concentration of an acid or base of an unknown solution. Okay, the word that you can go read the definition right here, but there's a one word, two words that I have to explain. The one is standard solution. The standard solution is a solution that we know its concentration and volume. Okay, and we're going to use this standard solution to determine the concentration of an unknown solution of a sample. I'll give you some example here. So if I have a sample or an unknown solution of hydrochloric acid, and unknown means I don't know the concentration, we will prepare the standard solution of sodium hydroxide. You know the concentration, you know the volume. Okay, and so we're going to use this standard solution or the information right here to find the concentration of this sample, hydrochloric acid sample. How to do that? Well, again, this is just a regular equation, right? Just regular chemical equation. All of them related by mole. Go back to stoichiometry. They all related by mole. This is a 1-to-1 ratio. Wait, hold on, sorry. If you know the concentration and the volume of the standard solution, which we do, you can calculate for mole, right? N equal to mv, you remember that? More sodium hydroxide, you can calculate for more hydrochloric acid. It's a 1-to-1 ratio. And then for more hydrochloric acid, if you know the volume of the sample, you can calculate for molarity of the unknown solution. Okay? Now, the difficult part right here. So how do you know the concentration and the volume of the standard solution? First of all, the molarity, the concentration, you have to prepare. So this one, this is use preparation, right? How much sodium hydroxide dissolved in water, you can calculate for the molarity of it. We learned about it already, right? Let's say we have the standard solution of 0.10 molar sodium hydroxide. If you want to know more of sodium hydroxide, you need to know the volume used. Okay, so this is how we're gonna do it. So we have, let's say we have 10 milliliter of the unknown solution. We don't know the concentration. We want to find the concentration of this hydrochloric acid solution. So you're gonna add the standard solution. So there's 0.1 molar sodium hydroxide into the burette. So we call this thing right here, it's a burette. Add up to, let's say, start at 0. You know, 0.1 molar sodium hydroxide solution. The starting volume is 0, and then we're gonna turn up the stopcock right here. The sodium hydroxide solution is going to come down, drop into the unknown solution and react with hydrochloric acid. Look like it. Turn on the knob. Okay, come down. So we're going to use up the sodium hydroxide solution, and we're going to turn it off. So no more reaction when these two sodium hydroxide and hydrochloric acid solution react completely. Okay, we stop right there. Well, the question is going to be, how do we know when to stop the reaction? When to not use any more sodium hydroxide? Well, we have to use the indicator. All right. In this case, we're going to use phenolphthalein because one, the color is really different between the acid area and the basic zone. Right. It change color around 7 to 8, which is that tells you where the acid and base the acidic solution change to the basic solution. Right there. Right. pH 7. pH 10, you see the color change right away. So before you start reacting these two solutions, we're going to add phenolphthalein, just a few drops, just a little, right, into the solution. Right now, this solution is in an acidic zone. This solution is acidic, so the color is colorless. Right, so phenolphthalein doesn't have color. And then we're going to turn on stopcock, a stopper. The sodium hydroxide will come down, and once the color change, which means that the amount of hydrochloric acid is all gone, all react with sodium hydroxide, we just stop the stopcock right away, right? And then read the final volume. So what happens? So we start with 0 milliliter, and then we end up with 20 milliliter. Okay, so we stop right here. So basically, the amount of sodium hydroxide, 0.1 molar sodium hydroxide that react completely with hydrochloric acid in this solution is 20 milliliter. Okay, right here you can calculate for more sodium hydroxide, and then you go all the way to molarity of hydrochloric acid. I'll show you. All right, so we want to know mole of hydrochloric acid. Okay, so more hydrochloric acid right here. So what we have is, we know that 0.1 mole of sodium hydroxide That's a concentration, mole per 1 liter or 1,000 milliliter, right? And we use 20 milliliter of it. So milliliter cancel out, you get to mole of sodium hydroxide, see that? And then from mole of sodium hydroxide, convert to mole of hydrochloric acid. So we're going to put mole of sodium hydroxide at the bottom, mole of hydrochloric acid at the top, 1-to-1 ratio. So mole cancel out, mole cancel with mole. So you get to that amount mole of hydrochloric acid. So this tells you that this sample of hydrochloric acid solution contains that mole of hydrochloric acid in it. Okay. Now the next one is find the molarity of hydrochloric acid. So molarity, so mole per liter solution, right? So we have that mole of hydrochloric acid per 10 milliliter of solution, which is the amount of sample that we have. And convert milliliter to liter. That's all you have to do. At the top, mole is mole, we good. At the bottom, convert milliliter to liter. So put 1,000 milliliter is 1 liter, right? So milliliter cancel with milliliter, you get 0.20 mole hydrochloric acid per 1 liter solution, which is 0.20 molar hydrochloric acid. Okay. All right. So it's quite long. All right. Let's do one problem together on the next video. Okay.